Hello, welcome to another one of my videos where I do the Everybody Codes challenge for 2025, many months after the challenge was posted and after all of the scoreboards are completely frozen. That's just the way it is. This time I'm going to be doing Quest 11. I don't have a huge amount of time to make this video, so if Quest 11 gets too long, we're just going to have to cut it. I'll stop the timer and pause the video recording, and you'll just notice this because the video will be longer. Anyway, yeah, so let me start the timer. And really start the timer. Hold up. There is something wrong with the timer. There we go. And let's start Quest 11. Grand Bite Father. Determination and Instinct. Time now. Nerd Masters. Dragon Ducks have vanished. The Bite Father. Fly like a scout. These ducks fly in a special formation. Start of the flight, the ducks group randomly in columns. Scout ducks in the flight is always perfectly divisible by the number of columns. Each column initially may contain a different number of ducks. Then the entire flock forms a series of exchange rounds until every column has the same number of ducks. Okay. First phase, each column of ducks checks whether the next column has fewer birds. If so, one duck moves to the next column. The next round begins with the first column compared to the second again. In the second phase, so one duck moves from the column with more birds. Okay, that. Two. Five. 3 and 4. Okay. So after round after round 6, no more moves can be made. Okay, so after 0 rounds, it's fairly straightforward here, but I'm really worried about off by 1 effects here. So so we start with 911496. We start with this. So these numbers are all after a round. So after round 6, we have that. And this is still after round 6, which was an attempt at, round 6 was a move to place that had fewer. Okay, and then round 7, okay, and then in round 7, we had that the 3 kept getting a 6, and then that became, okay. So we have to calculate the flight checksum after 10 rounds. Okay. Yeah, so I am worried about, okay, so duck data make int 0. Okay, so direction fewer next should have fewer is equal to true for round golang equals 0. Actually, I'm going to do this. Round is 1 and less than equal to 10. Round plus plus. Then found move duck data -1 if duck data idx if okay, wait a second. So okay, if fewer, if duck data idx is greater than duck data idx plus 1, found move is true, and duck data idx minus duck data idx plus 1 plus plus. Okay. If else next. if not, if next should have fewer, then okay. And then this is checksum. The checksum is calculated, I assume. Yep. CHK sum plus equals IDX times okay. Now, did I in fact remember to download? I don't think I remember to download this. I did. Okay. Shoot, I have to delete it. Everybody codes. Quiz 11. Okay. Now, let's just do go run quest 11. 253. Let's try this. Like I said, I am very worried about off by 1 errors, but I guess I didn't have to be. Okay. Find the number of rounds after which the flock is balanced. Balanced across all columns. Okay. So, copy, paste. Okay, so this will now be that, because I don't care, and actually I need to say round. And if we never find if we don't find a move, then yeah. So I'm going to change this to if not found move. And if not found, if next should have fewer, you do that. Else, okay, now we just, the round we are in, we just completed, so we'll just then return round -1. Okay, again, very worried about off by 1 errors, but I think I have it. So that round, we will have completed the round and there was nothing to do. Okay, yeah, I think that should work. Cool. Mascots. Exactly as long as it takes to balance. Count the current number of birds in each column. Luckily, you've practiced simulating the whole process in part 2. Easily calculate the number of rounds left for the flock to be perfectly balanced. Okay, so my bet is that I'm going to need something much better than before, although it doesn't actually seem that awful. So I'm going to initially, I'm just going to do this. Initially, I'm just going to do that. I don't know that it will work. Okay, what happened? What? Oh, duh. I meant to do problem 2. That's so. Okay, so this is going to take some careful examination to determine. Okay, we can calculate it out there, but yeah, I figured we'd have something like that happen. So let's look at part 11. Oh, so this is interesting. The first part doesn't happen. All we have is the second part. Well, that's interesting. Yeah. Finished forward after 0 rounds. Okay, so all I have to do to solve this is figure out if I finish the forward one, then how many times. Okay, so I have it in order, monotonic, non-increasing. So how many times, what is the total amount here once we've finished the forward one? How many more are we going to take to balance the whole thing? So what happens in one round? So in one round, in one one go through. That ends up increasing by 1. That goes down by 1, and that goes up by 1. Okay, so that ends up so I'm going to make a little change here, and I'm going to test this on with my part 2 data. I believe that we can, without screwing up the total round count, take stuff from the last and put it on the first until they are balanced. So move amount, min of duck data 1 minus duck data 0, duck data and duck data minus 1 minus duck data len duck data minus 2. Actually, let's just do that. And then duck data 0, move amount, duck data len duck data minus 1 minus equals move amount. Okay. So, remember part 2 came out to 2627235. Okay. So I can do that kind of a move. Okay, so once I've done that kind of a move, okay, so I think then what I do is I go up to where there is a bump, and then I go and I find the last spot there. So I go and I find the first and last spot where there is a bump, and I change it. No, because okay, so I can move from the first column from the last column to the first column. Okay. Now, if the first 2 columns are even, say, or the last 2 columns are even. Oh, also let's so I don't actually know that this works. Okay. Okay, so say that the first 2 columns are even. Then what happens is that we move something Okay. So if the first two columns are even, then we will end up moving 1 from the second column one from the third to the second column, and that goes all the way down to the next to last, no, okay, now, when those, okay, so if the first two columns are even, but then nothing else is, then we end up pouring stuff from the last column onto the first two columns until the last column becomes even to the one before it, and until the last column becomes even to the one before it, and here we have poured everything and we've poured it onto the second verse, second preference to the second column in preference to the first column. Okay, so yeah, I wish I could like just illustrate my head, because this would be a lot easier to for you to visualize, and it would make for a much more compelling video than just watching me think. But what I have is watching me think. So if we do okay, now what if the last two columns are even and the first column is not? Then okay, so if the last n are even, that's next has fewer. So if the last oh no, if the last several are even, we are in trouble. So that better never happen. If the last several columns are yeah. What happens if we do one, two, three, four, 5. Okay. Okay, keep adding. So then we have 21 and 5 columns. Now we have 26 and 6 columns, 31 and yeah, so what if we do 1, 2, 3, 4, and then 5, 5, 5, 5, 5, 5, 5. So we have 1, 2, 3, 4, 5, 6, that's 30, and 10, that's 40, and we have a total of 10 columns, so that's perfectly fine. Part 2. Problem 2. Okay. Round 6. Before round 1. Okay. Okay, so it still does work, but it works a little weirder than I thought in that. Okay, so if the last. So if the last several are all. What happens is we. Okay, so with each round, what happens? So we remove something from the end. Right, so what happened here? Move something from the end to something from the beginning as far left as it could go. Move something from as far right as it could go to something to as far left as it could go. And then we moved from Okay, so every time we move stuff, with every round, yeah. We take something from as far right as it could come from, and we put it as far so here and every so every round you're only gonna okay. So when we're done, we're all even. And every round moves something from okay. So if I keep track of number of ducks in columns, total number of ducks okay, so imagine that I talk about excess ducks and deficit ducks. And I talk about the number of ducks, yeah, okay. Func duck row debug duck data int. Okay. Tote 0 for duck tote plus equals ducks. Duck tote slash when duck data for ducks if ducks greater than duck average. Then okay, so I'm going to do a duck row debug. After each round. Duck row debug round duck data. Okay. Now, here's what I'm going to check. Okay, so these are going down. These are going down faster than I thought. Okay. Ducks are less than duck average. Small rows, plus plus. Big rows, small rows. Okay, now. Now, okay, so right now these are going down by 11. With each round, the number of excess ducks goes down by 11. Okay, so that's weird. It's weird that the number of big rows and number of small rows seems that like the total seems to be constant, because I would have expected this to disappear because we have a bunch of rows that are average, right? And it's all whoa. Yeah, so we have big rows and small rows right up to this point, and then okay, so these are all moving one at a time. So I guess the question I have is, when are we moving? Yeah, all these are how could we? So the question I have is, why initially are we moving huge number at a time? Okay, so the question is, what is going on here? What's going on when we move a huge number of ducks at a time? So I think what I want to do is I want to check out the first 10 rows, the first 10 rounds. Actually, yeah. Stop. Okay. So, okay, so we have here oh, okay. So I don't care about this initial thing. Um, okay. If not, next should have fewer. Okay. Oh, so the all of that other stuff I don't care about. Okay, so can I in fact do this here? So the excess is only dropping by 1 each time. Okay, so the excess drops by 1 each time, so I can use the excess to figure out where I am. Okay, so this, so what was the answer for part 2 when I properly did it? 2, 6, 2, okay. Okay, and now that plus excess. Okay, so what I have to do is that can work. Another thing I can do now, though, is right here. Right here, what I can do is I can calculate excess. Calculate excess. Add it to round. Okay, calculate excess, add it to round. Okay, I don't care about big rows and small rows. Return round plus excess. Yes. Don't care. Don't care. Okay. That's a big long number. Ah, crap. Okay, so I've got an off by 1 error or some shit like that. Damn it. Okay. Okay, let me make sure. What is my 262723.5? Okay. Okay, so calculate excess and add it to the round. Okay, so first off, let's change it so that round is okay, and this still gives us the same, yeah. let's say else. Okay. Let's put this back in. And let's here duck row debug. Oh. We don't actually use round, so. And then let's let's make sure that we're going down by 11, going down by 1 each time. Okay, so so the only thing I can think is I'm off by 1 because I never really do round 1. I don't like this, but nope. Yeah. Okay. Shoot. I really thought that this was a good thing. Every time we do this, because with every round, the excess duck count goes down by 1. Let me see if I can definitely prove this. Okay, so if when we're doing a round here and we've gotten through the forwards, doing a round, we've gotten through the forwards. Let me just check all the sample things. Let me copy that. Close that. Close others. Plain text into everybody codes input. Okay, that says 1579. And, yeah, 1579. Yeah, and then for this, oh, I'm off by 1 in part 2 here for this one. Why am I off by 1? Clock is balanced after just 11 rounds. Okay. Why am I off by... Let's you know what? Let's remove this part. Didn't I try that already though? 5 through 7. Whoa, that's very different. Okay, so clearly that jump that I did there, that jump was screwing us up. But with that, it works. Okay. Part. Oh, yeah. Okay. Let's do that. Yay! Okay. So, yeah, still took me an hour. Okay, so I don't know what I was doing with that jump, but it was clearly screwing things up very badly. Kind of weird, because I would have thought that it would have done a similar thing to the excess count. You know, moving from the biggest to the smallest, but, you know, whatever. I don't care. I've got the answer. Okay, so that's it. I will close this video out. Just a little... Okay, so let's just clean up here. We are not going to do... I'm not going to deduct... Okay, so if I eliminate that, can I still have the same answer? And yes. Okay. Forward last round is, let's take this out. Yes. Okay. Duck row debug. Yep. Okay. Well, one last check. Yep, and just because I've been checking the speed of these, let's do measure command. Okay, perfectly acceptable time. Okay, that's the URL. I'll put it in the description. And thank you for watching all of this, and goodbye.